AP is equal to BP. Tangent from the same external point will be equal in length. Do you understand here? Yes or no? Okay. Now, so tangents from an external point are equal in length. AP equals to BP. Then another property. The line from the center of the circle to the external point bisects the angle between the two tangents from the external point. That is OP bisects angle APB. That means you have the center here. You draw this line. This angle is equal to this angle. Understand what I'm talking about? Yes or no? Yes. Now the third one that can be drawn from this is this. The line from the center of the circle of an external point, the line from the center of the circle to an external point, bisects the angle between the radius OA and OB. That means OP bisects angle AOB, where A and B are points of contact of the two tangents in the circle. Now actually it's very simple. All of you look at this. Do you agree this one will be perpendicular? Tangent perpendicular radius. How about here? Tangent perpendicular radius. Do you agree that these two triangles are actually congruent? So if this is equal to this is equal to this, even by angle sum of triangle, this is equal to right? Can you see it? If I prove by SSS, side, 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 can you see it? It's also congruent, so these two will also be the same. Understand? So if I have an external point and I draw tangent, what are the three things? First thing, these two are equal in length. Next thing, these two angles are the same. And last thing, these two angles are also the same. Do you understand what I'm talking about? Yes or no? So, what's the short form? The short form will be tangent from external point. All three, you just write this one. Is that clear? I have finished all the four properties of the lines already. I'll go through the examples later. I'll clear with all this. Yes, okay, good. Now, because of this, right, tangent perpendicular to radius, once there's a 90 degrees, you can either use Pythagoras theorem or you can use Pascal. Can see it? Okay, so all these are also in. And mind you, because we have done radians, the angles need not be in degrees. It can be in radians. I can superimpose all the topics together. Do you understand what I'm talking about here? Okay, now, next. I'm going on to the angle properties. The examples I'll do later. Alright? Let's move on to the angle properties. Okay? Can we turn to page 203? Okay, page 203. Now, I want to emphasize some things here. Okay? That's okay. I want to block this thing off first. Okay. So that you can see. Alright. All of you look up first. If I have a circle and I have a center, now I join the radius like that. A, B. Now usually when I call an arc, I will call by three letters. A, C, D. Because if I call A, B, it can be the minor, it can be the major. Can you see what I'm talking about? Yes or no? Okay, now, can you see this arc here subtends this angle? Subtends. That means this arc will correspond to this angle, right? Okay? Now, what about the arc ADB? It will subtend which angle? The other one, right? Correct. This is what we mean by subtend an angle. Is that clear? Okay, now, in maths is like that. If they refer to this angle, hello? If they refer to this angle, they will just say angle AOB. It's understood, it's a smaller one. If they want the other side, they will tell you what? Reflex angle AOB. It's understood. AOB, once you know AOB, you can find reflex angle AOB. Because it's 360 degrees minus. Can you see what I'm talking about here? Yes or no here? So, and let me just show you again. The angle that is subtended by the arc ACB is actually this angle. Can Yes or no? Now, some people in the exam, they cannot see. Can I ask you, please rotate your paper to a certain orientation so that you can see? Because some people really cannot see the circles at all. Do you understand what I'm talking about? Yes or no? Okay, right? So this is what we have subscribed. Okay, now let's take a look at page 203. Okay, what it says here. Now I'm going to go through this. Okay, now they give you a variety of shapes and angles here and lines. Angle AOB is an angle subtended at the center by the circle by the blue arc AXB, and angle APB is the angle subtended at the circumference of the circle by the same minor arc AXB. Now what do you mean by that? Now all of you look here. This is the arc AXB, right? This is the center O, correct? This is the angle subtended at where? At the center. Now, if I produce, can you see it's still this arc that I start and end with? But this time around the angle is at where? At the circle, right? It's called angle at the circumference. Okay? So this is called angle at the center. This is called angle at the circumference. Subtended by the same arc here. Everybody clear? Okay, now let us look at this last one. I'm going to draw over there. Sit down also can fall down, it's very unbelievable. Okay, now all of you look up. I can have like that. Can you tell me which angle is subtended by the arc AYB? If I want AYB, this will be the angle subtended at the center. Alright. Where will be the angle subtended at the circumference? It will be this one. Can you see? Subtended means it must be starting and ending at the same time. Everybody clear with what I'm saying? I'm saying a few times because sometimes we get confused. Everybody okay? Alright, now let's take a look at the next part. There. Okay. Now consider figure 11B and C, okay? Identify the angles subtended at the center of the circle and the angles subtended at the circumference by the minor arc AXB. So let me do this too. By the minor arc AXB. Now, AXB is this one, right? So this is the angle at the center, this is angle circumference. Let's see. Yes or no? Now, AX and C. Okay, this one. Here. So this is the angle at the center. This will be the angle at the circumference. Can you see? Now, can you see that I can have many angles at the circumference? Can you see it? As long as it start and end at the same point on the arc itself. Everybody clear? Okay? Alright, look. So this is what we call angle at the center at the circumference. Now, next part. Figure 11.11b shows another circle with center O. Reflects angle AOB is an angle subtended at the center of the circle by the red major arc. Okay, AYB. Angle AQB is the angle subtended at the circumference by the circle by the same arc AYB. Now I have already explained this on the board just now. Are we okay? Are we okay here? Yes, okay, now what is the first angle property that we have? Is this one. Okay? Is this one. Now I'm going to draw it on the board. Now, what is the short form to write? This is about angle property already. Can I write below here? You must say angle at center equals to 2 times angle at circumference. This symbol here, CE on top, is the short form for circumference. Is that clear? Okay, so angle at center equals to twice angle at circumference. Now, what do we mean by that? I want everyone to look at the board. If I know this is 80, right? This is angle at center, correct? This will be angle at where? Circumference. How much will this be? 40. Understand here? Understand here? Angle at center is twice angle at circumference. Now, I need to warn you. If the line goes like that and like that, this is still angle at the circumference. It is still 40. Just that this line coincides with the radius. Can you see? Yes or no? Okay. Another thing that I want to tell you, all up. Do you agree that this is still angle at the circumference? This is also 40. Do you understand? So angle at center is twice angle at circumference. Understand? That means if I give you 40, you must also know that this is 80. Understand what I'm talking about? So since this is the first angle property, are we clear? Angle at center equals to twice angle at circumference. Okay? Now, so this is the first angle property that we have. Next, page 207 at the bottom. This one. This one, the short form is called right angle in semicircle. Now, I want to tell you that this is actually from number 1. Now, if I have a circle and this is the diameter, do you agree this angle is 180? I'm talking to you. Do you agree this angle is 180? So, if I have an angle at the circumference, it must be 90, right? Actually, it follows from 1 though. Angle at center is twice angle at circumference. Can you all see that? Yes or no? But we cannot use that property. We must say what angle is semicircle. Everybody okay? But this line must be what? The diameter. It must be a semicircle. If not, it doesn't work. Everybody clear? But a lot of students will be confused. Let me draw you another diagram. In the exam, right, they're very confused. Once they see like that, right? Oh, got one line, so 90 degrees. Or this one, they never say pass through center. They also say 90. Cannot. You must make sure that that one is a diameter. Then you can see that is what angle is semicircle. Are we okay? Second property of angle. Understand? Okay, third one. What do we have? Okay. Now, I need to explain something first, which I already explained it yesterday actually. Okay. Now, turn to page 211. 211. This is the next property. Angles in same segment. Okay? Angles in the same segment are equal. Now, let me just show you something. All of you look up. I have a circle. I have a center. Now, do you agree that this is angle at the center? Yes or no? Now, this will be angle at the circumference, right? All these angles are angles at the circumference. Agree plus? Now, just now I say, right, if this is 80, how much are all these? 40, right? Correct. Can you see all of them are the same? Why is it called angle at the same segment? Let me just explain to you, right? Can you see that if I draw a line here, this will be a segment? This is the other segment, right? Actually, it's called the opposite segment. Understand? Can you see that all these three angles lie on the same segment? Lie on the opposite segment. That means they are all equal. Understand? That means what does it mean? If I have a circle, and then I have like that, if this is 30, all these will be what? 30, because they are angles in the same segment. Okay, but some people like to see as butterfly, which I don't understand why. They call this butterfly wall, which I do not agree. Okay, butterfly don't look like that. You understand? But it's like that. Everybody okay? So angles in the same segment are equal. Actually, it boils down from this part again. Can you all see what I'm talking about? Now, I told you already. If this is a segment, the other side we call what? Opposite segment line. Correct? Okay. Then we go on to the last property that we are going to use. Okay. Look at page 213. Now, I do not like the property given. You can use this property, of course, not an issue at all. So property 4, I'm going to write on the board. Property 4, you can say angles in opposite segment, or I always use the second one. Opposite angles of cyclic chord. I'll explain to you what it means. You take down first. Why is it that I want to use cyclic chord? Because I want you to check that it's a cyclic chord before you can use it. Okay, and I'll explain to you what is a cyclic chord. Alright? Now, this abbreviation says that angles in opposite segments are supplementary. That means this angle plus this angle will give me what? 180 degrees. Now, how come I don't use opposite segment? I use cyclic chord. Now, let me explain to you what is a cyclic chord first. To qualify as a cyclic chord, all 4 vertex must touch the circumference. You understand? Understand? To qualify as a cyclic chord, all 4 vertex must touch the circumference. That means this one plus this one will be what? 180. Understand? This one plus this one will be 180. Now, why do I prefer this to this? Because some students are nonsense. Is this even a cyclic chord? Did this one touch the circumference? No, but once they see something like that, they straight away cyclic chord. You understand what I'm talking about? So, if you write opposite segment, you must know what you're talking about. Of course, I don't try shorter. Angles in opposite segment, they end up to 180. But if I say opposite angle of cyclic chord, then I will remind myself that I got to check that it's a cyclic chord. Do you understand? Now, let me give you another example that students always think that it's a cyclic chord. Is this a cyclic chord? Is this a cyclic chord? No. But some students will still try, oh, this one plus this one is 180. It's not. Can you see this guy is not even at the circumference? Do you know what I'm talking about here? Okay? That's why I prefer the second short form. Understand? But you're not wrong if you use the first short form. Are you clear? It's called angles in opposite segment. Okay, I repeat all the 4 things. Number 1, angle at center is twice angle at circumference. Second one is what? Right angle in semicircle. The last one, I write it on top because I'm afraid that those at the back cannot see, so I'm going to write it down here. Angles in opposite segment or opposite angles of cyclic chord. Are we clear so far? Are we clear so far? Okay. So, what's the moral of the story? The whole chapter only got these 8 properties. Okay? And reasons must be written when you do your questions. Okay, you will say, find with reasons clearly stated. Okay? Now, can you see that the first 4 talks about length? How about the last 4? It's not about angles. Okay, I'll just repeat. Angles in same segment are equal. Angles in opposite segment adds up to what? 180 degrees. Are we clear so far? Are we clear so far? Can or cannot? Yeah. So now I'm going to go through the examples. Are we okay? I'm going to go through the examples. Okay. Let's turn back the textbook. Alright, to example 1. This one. Now, I'm just going to go through how to solve the reasons and everything. I will do it when we are doing the exercises. Are we okay? Yeah, that will save us some time. Oh, look at the board. Don't look at the textbook. Just look at the board. The figure shows, in the figure shown below, XY is a chord of a circle with center O. The point P lies on XY such that OP is perpendicular to XY. Okay, given that XY is 18, OP is 12, find the radius of the circle. Now, do you agree that radius is a circle is either OY or OX? Correct? If this is 18, right? I know this is 99. By which one? By which one? Number 1, right? Perpendicular bisector of chord, right? Can you see it? Then, if this is 9, this is 12, I can find this one, right? Using what? Using what? Pythagoras theorem. Can you all see what I'm talking about? Can you see this is 9, this is 12, I can use Pythagoras theorem? I can find this one? Yes or no? Hey, I'm talking to you, like, are you awake or not? You know what I'm saying? Okay? So let's take a look at the presentation. Okay? We know that xt will be 9. Alright? Then by Pythagoras theorem, you will get 15. Is that clear? Now the important thing here is that you must write this statement. Perpendicular bisector of chord. This one no need to say. Just write perpendicular bisector of chord. Are you clear? Are you clear? Okay, so this is the example 1. Now, example 2 is quite a challenging one. Let's take a look at the question. Okay? The lengths of 2 parallel chords of a circle of radius 12 cm are 8 cm and 14 cm respectively. Find the 2 possible distances between the chords. Now, I need to show you something. All of you look at bone slate. Now, I need to teach you how to read the question. The lengths of 2 parallel chords of a circle of radius 12 cm are 8 cm and 14 cm. Now, do you agree I can have 8 cm here? I can have 14 cm over the other side. Alright. Okay. Now, class, you look I can also have 8 cm here, 14 cm here. Can you see it? Are we clear? Okay. Now, if I want the distance between these two, is this one plus this one, right? What about if I want the distance between these two? I must find this, then I find this, I minus off, right? Can you see? Yes or no? That's why there are 2 possible sets of answers. Now, what if I only want this side? Okay, how will the question phrase it? They will tell you the 2 chords lie on the same side of the circle. It's on the same side. Understand? How about this? Opposite sides. So you must read question carefully and also just blindly do it. Everybody clear with what I'm saying? Okay, they tell you the radius is 12. That means this guy is 12 now. Can you see? Can you see? Then this guy is also 12, right? Everybody okay? Then I know this is perpendicular. I can use Pythagoras theorem. I find this, right? Everybody clear? Okay, now for this part, right? This is also 12. This is also 12. I can use Pythagoras theorem, find this, then after that I minus, right? I can get the answer. Is that clear? I'm not worried about the working. You can do it. It's just that you know how to design it. That's how done. Everybody clear? So I'm telling you how to read questions. This one is called on the same side of the circle. This one is called on the different side, opposite side of the circle. Are we clear? Yes or no? Okay, good. Now I'm going to show you the working now. You can read through the textbook. Okay? They will add up. Can you see the first case? They will add up. Alright? I trust that you can read that. Clear one, is this okay? Then the next one, can you see that they just minus off? You can get the answer. So it depends on whether the 2 chords lie on the same side or lie on opposite sides. I just want to know, have I made myself clear? Have I made myself clear? So you got to answer the questions accordingly. Are we okay? Alright, okay, good. Now let's try example 2. Next. Example 3. This one is very simple. Example 3. All of you look here. Okay? In the figure, AB and PQ are equal chords. They only tell you these 2 are equal. Look at the box, please. If these 2 are equal, that means and N is the midpoint of PQ. If it's midpoint, confirm this one 90 already, right? Remember perpendicular bisector I thought. Then find the length ON. Find this length. Alright. This is what they want, right? Find this length. So how? They tell you ON is what? ON is 7. So ON will also be 7, right? Because they're equal chords and they're equidistant from the center. Do you agree? Yes or no? So this is a very straightforward one. So let's take a look at the answer here. So because of equal chords, straight away is 7 here. No need such things. Everybody okay? Can or cannot? Can, okay. Last question. The last two questions. That is example 4. So I just want to know if I do fast. Because if I go very slow, you'll be very bored. Because this one is just apply only. You understand? Just that all the different property must keep in, that's all. Everybody okay? Okay, now let's take a look at this one. Wow. Try to set the wrong place. Okay. In this figure, Px is a tangent to the circle with center O. Given that Px is 6.8 cm and Ox is 4.3 cm, find angle OPX. This one. Now, first thing you must realize, this angle is what? 90. Which property? Tangent perpendicular radius. I want to find this one. Can you see I use tangent opposite over adjacent? I can get straight away. Can see it? Yes or no? Opposite over adjacent. Okay? Okay? Now, the length of OP, very easy. You use what? Pythagoras theorem. You can get. If you don't want, you can also use sine, cosine. You can also find. Am I right to say that? Okay? Last part. The area of triangle OPX. Now, this will be right angle. Even you don't know bottom, you can still find this one, right? What's the area of a triangle? Half base times height off. You get the one. Okay? Or some people will be very funny lah. They will say half AB sine C lah, when sine 90 is 1 lah. Okay? Don't need so troublesome. There's some kaypoh will go and use this one, then half AB sine C. Okay? Now, please class, I know you are correct. Can you go for the more efficient way and more effective way? Don't just blindly because I learned half AB sine C but very scary, I must use. Okay? When half base times height will be enough. Everybody okay? Alright, good. So that is your example 4. I just want to know, am I too fast? Can you follow? Can, okay. Next, let's look at example 5. This was the last example for the first 4 properties. I want all of you to look at the picture and I'm going to explain to you. Okay. Now, if you look at the presentation of the solution on top, can you see they go and write down all the properties? You are expected to do that as well, but you can shortcut over there. Understand? No need to spell everything. Okay, let's look at the first thing first. In the figure, PA and PB are tangents to the circle with center O. Given that OA is 8 cm, angle OPB is 26, find angle AOB. I want to find this angle. Now actually it's very simple. Do you agree this is 90? Why? Tangent perpendicular radius. This is also 90, right? Alright. This is 26. This will be 26, right? They want to find angle what? AOB. That means the whole thing here, right? Correct? Do you agree that these 4 angles add up to 360 degrees? Angle sum of what? Quadrilateral. Then you just get angle AOB straight away. Now how I know they want this angle and not the other angle? If I want the other angle, what would they say? What would they say? Reflex angle AOB. I'm telling you now. Okay, so in exam don't have ask me again. Clear? Okay? Alright. So they will give you all these answers. Okay? Then they will find AOB as 128. Are we okay? Can or cannot? Alternatively, if you do not want to use angle sum of quad, you can just find one angle, right? Then you times what? Times 2 also can, right? Correct? Because these two triangles are congruent. That's it. Okay? Alright, good. Next question, what did they ask? The length of AP. They want, this one 90. They want the length of AP. You know this is 26. Can you see I can use tangent to find? Always use the info given in the question. Okay? Unless cannot, then you use the one that you find yourself. What I'm worried of is that the one that you find yourself may be wrong. That's the problem. Are we clear with all this? Yeah. Okay, last part. The area of the polylateral OAPB. You just find the area of one, right? Then you times up. Times 2 can already. This one already find AP, right? Alright. Then you just times base times height. You see? You get a triangle, then you times 2. You get the whole polylateral. Are we clear with this question? Are we clear with this question? Yes or no? Yes or no? Yes, huh? Okay, go. Now, next. I'm just going on with the examples. They're all together. Many examples, but I'm just going to go through 2 more. Then after that, I will just give you the questions for exercise 11A. Will that be okay? Will that be okay? Then for tomorrow, you will do what I have assigned on the HPL and just the 11A homework. That's all. Yeah. Then 11B will consolidate on Friday. Next week, then you'll bring your A-Maths textbook. Will that be okay? By the way, I've already photostated the last year's exam paper for you. Okay? Then I will give it to you by end of the week or next week, so that you can try. Now, you know this, I want to say this, for E-Maths, right, you have 2 papers. All 90 marks. This is Cambridge standard. 2 hours 15 minutes each. So it's equal weightage already. Because since last year they changed the syllabus. Okay? Now for A-Maths this year, right, we cannot have 2 papers because the topic is too limited. So we only have 1 paper. Understand? And it's also 90 marks, 2 hours, 15 minutes. The old syllabus is that paper 1 is 80 marks. And it's 2 hours. And this one is 100 marks, and this is 2.5 hours. Okay, so now they want to make it equal weightage. Do you understand? So I repeat, E-Maths got 2 papers, paper 1, paper 2. A-Maths only 1 paper because we don't have enough topics. But next year we'll have 2 papers. Do you understand? Okay? Then don't ask me what is coming out in paper 1 and paper 2. You study everything, but whatever comes in paper 1 will not come in paper 2 again. The concept. That means the concept. Like for example, A-Maths, right? Paper 1 already got major frequency theorem. Paper 2 will not have. You understand what I'm talking about? Let's say R formula came out in paper 1, then R formula will not come out in paper 2. Understand? But it doesn't mean that R formula got paper 1, the whole figure will not come out in paper 2. There's other things like proving and everything. Is that clear to everyone? Okay? So you just take the complement. So are we clear about the format of the paper? Okay, you have to be very clear about the format. Don't go there and gong. Okay? Paper 1 is usually about 20 questions, 20 over questions. So you're going to divide 1 question, how much time? Paper 2, the last question for E-Maths is PRWC. Problem in real world context, 10 to 11 marks. First 3 or 4 is can score 1. Last part is must reason. Understand? My advice to my students is always 3-4 marks go and get first. The reason one can get, cannot get, never mind. Because even if you lose 7 marks, right, 83 upon 90 is still A1 go. But you cannot have this part mentality, everything 1 mark go 1, go 1, then after that 0 upon 90. Then you tell me, oh, 0 upon 90 is still A1. Okay, that's confirmed G10, not even F9. No effort. Okay, F9 is you try, you fail. G10, right, not so much those parts, you really start sleeping. That's called G10, no effort. Okay, now let's take a look at the first example. Angle general properties. Okay? Can we look at this one? Hold on, look at this one, please. I'm going to explain on the board. Look at the board. A, B, C, D are 4 points on a circle with center O. Given that AOD is a diameter of the circle and CAD is 37, find angle COD. Okay. This one, a lot of people cannot see. Right? Oh, look. CAD is this one, right? This is 37, right? Do you agree that COD is the angle at the center? This is angle at the circumference. So how do I find COD? 37 times what? Times 2, right? So you get a 74. Are we okay? Are we okay here? Yes. Next part. Find angle ABC. This one. I'm going to teach you something. A lot of you, right? Do you first agree that this one will be a 74 degrees? Can see? I'm talking to you, can see? Yes. How many of you will say, oh, this one is isosceles triangle? The question never say no. Do you understand? Now I'm going to draw something for you. How much is this angle that I shaped? 180 plus 74. So much? 2? What? 180 plus 74. 254. Good. This is where I want to tell you. Can you see this is the angle at the center? This one is the angle at the circumference. Got to rotate. Can you see? Cannot, right? I draw it. Ready? Can you see this is angle at the center? Then from the same arc, I draw. This is angle at the circumference, right? So how do I find ABC? 254 divided by what? 2. I get this one. This is where I say students cannot see. Because when you have too many things to put in both, somehow like that, right? I can put in similar triangles now. Then you're supposed to prove it again, then more targets in here. Because I don't even see one of them. Can you all see what I'm talking about here? It can be confusing. So it's 254 divided by 2, angle at center, equal to cross angle circumference. I will get a 127 degrees. Are we clear? Are we clear about the first example? Okay, so this is example 6. I'm going on to, I think I will just stop here. Like example 7, I'll do the other side. Because you'll be very confused. Are we clear? Now I want to leave you with this one. Why is that so? Because some people will think that this topic is very simple, no need to worry, but actually you have to worry because why? You cannot see. You understand? Picture give you also cannot see. Okay, now my advice to you is this, in the exam, don't want to do everything, then you cannot see anything already. You understand? In pencil, when you clean out, it is wrong. You understand? If not, the whole figure is disfigured by you, I have no more figure to give you. You understand? Okay? Alright, now, what is it on the Emacs textbook now? Sorry, textbook. Emacs content page. What number is it now? 5, 6, 7, 8, 9, 10.
Oh, is this one?
No, right, 6. Okay. Did I fill out WA3 already? I have. Okay, so now write 6. Okay, 6. Today's date. one first because I want it by Friday. And one is until next Sunday. Understand? Okay. Now I still have you know why? This class I don't give won't do one. You just throw the textbook in the under the table and then you will do one. Okay. Okay. Now, I'm going to read my instructions once more, okay? I still got a lot never do that. This is just like about 60% of the whole exercise. Okay, I don't know how many. Okay, listen. This will be due when? Friday. I want this on the full sketch, this in the notebook. Understand? Vincent, pick up. Okay? For this one, full sketch. Ladies and gentlemen, all diagrams must be drawn. No need to draw the scale, but at least you must sketch and tell me where you have labeled. Understand? Okay, now, I want to warn you again, don't use a 5-cent coin or a strepsil tablet and draw the circle and I cannot see. Okay? Draw a decent circle. Do you understand? Okay? So, on Friday, I want these 2 sets of work and I will finish up the whole chapter on Friday. Next week, we will start our A batch. Are we clear? Okay, alright. We have stopped the video.